सोचने से कहाँ मिलते हैं तमन्नाओं के शहर, चलना भी जरूरी है मंजिल पाने के लिए. Hello everyone, myself Chandrasekhar, welcoming you all to the India's largest, the best and your favorite live learning platform, that is BYJU'S exam prep. So for those who are going to appear for Barc 2023 examination, as you all know, Barc is a golden opportunity for all the engineering aspirants. So for them, the session is planned. This session is for formula revision through questions for the subject of fluid mechanics. So please guys, do let me know if I am audible and visible to everyone so that we can start. Those who are watching me live, please respond through the comment section if I am audible and visible to all of you. So in this session, we will be discussing some beautiful numericals, and through the numericals only we will revise our related formula. All right. So before I start the session, let me quickly introduce myself for those who are here for the very first time. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience in the field of GATE, IES and PSUs. I have also cleared engineering services examination, worked in Steel Authority of India Limited for a couple of years, and I have also worked in a private consulting firm for more than 2 years. So with my experience, my knowledge, I will try to make the concept simple, easier for you to understand through this session. If you have any doubt, anything to discuss, you can always comment, always write through the comment section. All right. But before that, please mark your attendance by writing in the comment section if I'm audible and visible to all of you. And during the live class, you can discuss your doubts with me. But after the class also, you can connect with me through the mail ID which is there on the top of the screen. chandra.shekhar@byju'sexamprep.com. Hi Nagaraju, welcome, good morning. Namaskar, Adab, Suprabhat, good morning, Sat Sri Akal, Assalamu Alaikum. You can also connect with me through the Telegram group, that is Mechanical by Chandrasekhar. The link is also mentioned on the bottom of this screen. Once you become part of my Telegram group, you will be getting all the exam notifications, upcoming exam notifications, along with the PDF of this session will also be provided to you, and the various important sessions we are going to plan for you guys, for your benefits. That information will also be shared through the Telegram group only. All right. And before we start the session, please keep your pen, notebook and calculator handy. Try to solve the questions on your own. The questions are simple. The objective is to revise the related formula, related concept. That is why I have kept the numericals simple only, so that you can brush up your fundamentals, you can brush up your formula revision. All right. So there is an important information I would like to share with you all who are aspiring for ESC 2023 examination, those who have already cleared prelims and those who are going to appear for mains examination. We are going to start wonderful practice course for all the 4 branches, so that you will be able to understand beforehand how to present your answers, subjective answers in your mains examination. So the course is going to be started from 3rd of April, that is Monday onwards. Please do enroll yourself and do share this knowledge, share this information, share this announcement with all your friends and colleagues who are going to appear for ESC 2023 examination mains. It is going to be very, very fruitful and very beneficial to get the highest possible score in your mains exam. All right. So let us start with the first and the basic question from the fluid properties. Newton's law of viscosity, very, very important. Either there will be a numerical asked from the Newton's law of viscosity, or there is a theoretical question asked from the viscosity, like the the unit of viscosity or how the viscosity varies with temperature. So you should understand about the viscosity, very important property of fluid. What exactly is the expression or the statement for Newton's law of viscosity? Can anybody let me know? When we analyze the adjacent fluid particles, motion of the adjacent fluid particles, relative motion of the adjacent fluid particles, we develop this expression: d theta by dt is equal to du by dy. The unit will be second inverse. Rate of angular deformation will be equal to velocity gradient. All right. Please write me in the comment section, those who are watching me live. And according to Newton's law of viscosity, shear stress developed in the fluid will be directly proportional to d theta by dt or du by dy. Shear stress developed is directly proportional to rate of angular deformation or velocity gradient. That is the Newton's law of viscosity. So it relates the shear stress and rate of shear deformation. It does not relate the velocity gradient. This is not Newton's law of viscosity. D theta by dt is equal to du by dy is not Newton's law of viscosity. Newton's law of viscosity says that shear stress developed in the fluid will be directly proportional to rate of angular deformation, rate of shear strain, rate of shear deformation, or velocity gradient. If we convert it into equation, so tau can be written as mu, the proportionality constant, into d theta by dt. That is the equation form. The constant of proportionality is called as coefficient of viscosity. This is called as coefficient of viscosity. Or we can also call it as absolute viscosity. Or we can also call it as dynamic viscosity. What is the unit of coefficient of viscosity? Absolute viscosity or dynamic viscosity? The unit of mu will be Pascal second or Newton second per meter square, or SI unit is kg per meter second. So the dimension formula is m1 L minus 1 T minus 1. There is another viscosity defined, kinematic viscosity, that is dynamic viscosity per unit density. That is called as kinematic viscosity. The unit is meter square per second, SI unit. Momentum diffusivity, that is called as kinematic viscosity. The CGS unit is stock or centimeter square per second. So one stock is equal to 10 to the power minus 4 meters square per second. And CGS unit of dynamic viscosity is dyne second per centimeter square or gram per centimeter second or poise. And one poise will be equal to 10 to the power minus 1 Pascal second. That is how you should be understand the conversion. Do you understand it? Is this clear? Moreover, as the temperature increases, viscosity of liquid decreases because cohesive force is the dominating parameter. As the temperature increases, viscosity of gas also increases because molecular collision is the governing parameter, right? And if the velocity profile is linear, du by dy is obtained from u as a function of y. If the velocity profile is linear, if the velocity profile is assumed to be linear, then we can say for linear velocity profile, tau is equal to shear force per unit shear area is equal to mu into v by h, that is constant. That is not a function of y. All right. Is this clear? So that is about the Newton's law of viscosity or the viscosity, very important property of the fluid. Let us move to the next one. There are two properties which are very important for your examination point of view. One is the viscosity, another will be the surface tension. So the next question, the pressure inside a soap bubble of 50 mm diameter is 25 Newton per meter square above the atmospheric pressure. The surface tension in soap film would be. Now this is from the application of surface tension. Application of surface tension. So we can say delta P for a liquid drop is given by 4 sigma by diameter of the drop. The shape of the drop is always spherical because of surface tension. Why? Because the surface tension always minimizes the surface area of the liquid, or that is equal to delta P for a air bubble. Because of single interface, liquid drop and air bubble are having single interfaces. For a soap bubble, it is having two interfaces. There are two interfaces. So delta P for a soap bubble is equal to 8 sigma by D, or we can say twice of delta P for a liquid drop, because in liquid drop there is one interface, in a soap bubble there are two interfaces. That is another application. And the third one is delta P for a liquid jet. The shape of the jet is cylindrical. That will come out to be 2 sigma by D. Diameter is very less compared to the length. These are the various application of surface tension. There is a high possibility that the question can be framed from any one of these formula. All right, what is the correct answer? So it is about a soap bubble. The pressure difference is 25 Newton per meter square. So what is the sigma surface tension? So we can say sigma will be equal to delta P into D by 8. Put the value, you will get the answer. Are you getting 0.156? 0.156 Newton per meter is the unit of surface tension. Newton per meter or joule per meter square is the unit of surface tension. Surface tension can also be defined as the amount of work required. The amount of work required, that is joule per unit change in surface area of liquid. That is meter square. So joule per meter square or Newton per meter is the unit of surface tension. So the correct answer is option A. For question number 2, option A will be the right answer. The next one, question number 3 on the screen. There is an equilateral triangular plate having the side same B. This is also B. This is also B. Is immersed in water as shown in figure. The center of pressure below the water surface is at a depth of. The question is not about the center of gravity. The question is about the center of pressure. Depth of center of pressure from the free surface, that is HCP, will be how much? So what is the formula for a vertical plane surface? Vertical plane surface, the formula for depth of CP is x bar plus Ig by Ax bar. For a vertical plane surface, the depth of CP from the free surface is given by, what is x bar? X bar is the depth of centroid. X bar is the depth of centroid of the plane surface from the free surface. So the value of x bar will be, here x bar will be equal to h by 3, isn't it? H is the height. What is the area? Area is equal to half into B into H. Ig will be the moment of inertia passing through the centroidal axis parallel to the base. So it is B into H cube by 36. Put the values, you will get the answer. What is the correct answer? HCP is equal to x bar, that is h by 3, plus BH cube by 36 into BH by 2 into h by 3. So this BHH getting cancelled out and it will be 6. So h by 3 plus h by 6 will give you the answer. How much is that? 2h plus h. 3h by 6, that is h by 2. H by 2 is the right answer. Option D is the correct answer. We can also find out the hydrostatic force for a plane surface. The hydrostatic force and the depth of CP. If it is inclined plane surface and theta is the angle of inclined plane surface with horizontal, the formula is rho g a x bar. and HCP is x bar plus Ig by Ax bar sine square theta. For a vertical surface, for vertical plane surface, theta will be equal to 90 degree. This formula will remain same, but if theta becomes 90 degrees, sine theta becomes 1. So x bar plus Ig by Ax bar will be the expression for depth of Cp. If it is a horizontal surface, then theta will be 0 degree and the formula will remain same, rho g Ax bar. If theta becomes 0 degree, sine theta will be 0. So HCP is equal to x bar. For plane surface, different orientation of the plane surface, these are the formula you must memorize. What is x bar? X bar is the depth of centroid of plane surface from the free surface, of the liquid. All right, let us move to the next one. Question number 4. The vertical component of force on a curved surface submerged in a static liquid is equal to. What is the correct answer for question number 4? The vertical component of force on a curved surface. For a curved surface, whenever there is a curved surface, this is, let us say, free surface. For a curved surface and the liquid is like this. For a curved surface, if we want to find out the vertical component, so weight of the fluid which can be contained by the curve up to free surface is giving the magnitude of Fv. Weight of the fluid which can be contained by the curve up to free surface, and the direction will be decided by the actual contact. If the liquid is in contact from the top, the direction will be downward. If the liquid is in contact from the bottom, the direction will be upward. So it is always the weight of the fluid, rho of fluid into G into volume of this fluid. Volume of the fluid which can be contained by the curve up to free surface is vertical component. And how to find out the horizontal component? Take the vertical projection of the curve. Once you take the vertical projection, then vertical projection is treated as a vertical projection can be treated as a vertical plane surface, and apply the formula rho g Ax bar for the magnitude of force, and the depth of Cp also you can find it out by using the formula x bar plus Ig by Ax bar. So that is how the horizontal component is calculated separately by using the vertical projection of the curve, and the vertical component is calculated in a different manner by assuming or by visualizing, by imagining how much fluid the curve can contain up to the free surface. The weight of the fluid which can be contained by the curve up to the free surface will be the magnitude of Fv, and the direction of Fv will be decided by actual contact. For an example, if there is a curve and if the liquid is on the right hand side and here is the free surface, let us say here is the free surface. If we want to find out the vertical component, on this curve, then we will always imagine how much fluid it can contain up to the free surface. Magnitude will be decided by this volume, not the volume below the curve. The magnitude will be decided by this volume into rho fluid into G, and the direction will be upward. Why? Because the actual fluid is in contact from the bottom. I hope this is clear. So the answer to this question, vertical component, is weight of the liquid above the curved surface. B is the right answer. Yes, Tarun. Well done. Good, good. The next one. Find out the answer to the next question. A metal ball which weighs 9 kilonewton in air and 7.5 kilonewton in a fluid of specific gravity 0.75, then what will be the specific gravity of the ball material? When a body is immersed in a fluid, there is a downward force, that is the actual weight acting. Along with that, there is a buoyant force acted by the fluid in upward direction. So we can say apparent weight of the body. Apparent weight of the body is equal to actual weight minus buoyant force. That is called as apparent weight of the body, which is submerged in the fluid. The first fluid is air, the second fluid is having a specific gravity 0.75. So we can say actual weight minus buoyant force by air. Good morning, Amit. Welcome. Actual weight of the ball minus buoyant force by air is equal to 9 kilonewton. Do you agree? And because the buoyant force is a function of density of the fluid and density of air is very, very small. And because the density of air is very small, we can say buoyant force by air is very, very small. We can ignore the buoyant force by air. So we can say actual weight of the body, that is equal to density of the ball into G into volume of the ball is equal to 9 kilonewton. But the other fluid, so we can say apparent weight, actual weight minus buoyant force by the fluid is equal to 7.5 kilonewton. What is the buoyant force by the fluid? So we can say buoyant force by the fluid will be equal to rho fluid into G into volume of the body, because it is completely submerged, 9 minus 7.5, that is 1.5 kilonewton. So if we simplify this, density of the body into volume of the body, it is into G is equal to 9 kilonewton. Density of the fluid into volume of the body into G, that is the buoyant force, is equal to 1.5 kilonewton. If we divide these two, volume getting cancelled out, G getting cancelled out, so we can say that is equal to 6. So density of the body is 6 times of density of the fluid. If we divide by density of water, left hand side and right hand side, then what is that ratio of density of body to density of water? That will be specific gravity of the body is equal to 6 times. This is the specific gravity of fluid, that is 0.75. So the specific gravity of the body will be 4.5. What is the specific gravity of the body? That is 4.5. Buoyant force, according to Archimedes' principle, buoyant force exerted by the fluid on the body, immersed body, is equal to weight of the fluid displaced by the immersed body, and it always acts in upward direction, right? That is the concept. Here the weight of the body is greater than buoyant force. That is why there is an apparent downward force or apparent weight which is acting in downward direction. If we want the condition for equilibrium of a body, then the actual weight should be equal to the buoyant force. Then the body will be in vertical equilibrium, right? But here the body is not in vertical equilibrium. The weight of the body is greater than buoyant force. That is why the body is having a tendency to move in downward direction. That is why there is a reading of weighing machine. If the actual weight is equal to buoyant force, the reading of weighing machine will become 0. The next question. The next one, question number 6 on your screen. Can you find out the answer for question number 6? A body is floating as shown in figure. It is about a floating body. The center of buoyancy, center of gravity, and meta center are labeled as this. Center of buoyancy is lying at the bottom, then meta center, then center of gravity. The body will be in. For a floating body to be rotationally stable, meta center must lie above center of gravity. For a body to be rotationally stable, meta center must lie above center of gravity. If the meta center is lying below center of gravity, it is rotationally unstable. And if M and G coincide, with each other, then it is neutral equilibrium. That is for a floating body like a ship. Ship is an example of floating body. For a completely submerged body, if we talk about a completely submerged body, then it will be rotationally stable if center of buoyancy is lying above center of gravity. If center of buoyancy will be lying above center of gravity, then the body will be, the completely submerged body, like a submarine will be rotationally stable. All right. So you should remember these short tricks. BAG. B means center of buoyancy, A for above, G for center of gravity. If center of buoyancy is lying above center of gravity, the completely submerged body will be rotationally stable. And for partially submerged body or floating body, MAG is the short trick. Meta center must lie above center of gravity. All right. Now, can you let me know, for a floating body, is there any possibility that G lying below B? Is there a possibility? Or G coinciding with B? Is there a possibility? For a floating body, I am talking about a floating body. In case of a floating body, can there be a possibility that center of buoyancy lying above center of gravity or center of buoyancy coinciding with center of gravity? When it is so, when it will happen, then floating body is always rotationally stable. In those situations, floating body will always be rotationally stable. Always be rotationally stable. All right. You should remember. So many students think that B cannot lie above G. B is always lying below G. That is not true. There is a possibility in case of a floating body that center of buoyancy can lie above center of gravity also. Center of buoyancy can coincide with center of gravity also. In both these cases, meta center has nothing to do with it. In both of these cases, a floating body will always be rotationally stable. But when B is lying below G, then the location of meta center becomes important to decide the stability of a floating body. I hope this is clear. Is this all clear to everyone? Please give me thumbs up. Please give me yes. And do not forget to like and share this session to all your friends so that other students can also get benefited. If they are not able to join it live, they can watch the recording to get the concept fundamentals clear. There is a scholarship test on 2nd of April, that is on Sunday at 12 noon. Once you appear for the scholarship test, based on your performance in the test, you will be able to avail the discounts on our various courses. Plus, you will be able to understand your preparation level, whether your preparation is well, fine, or you need to improve it. Accordingly, you can plan your strategy, you can plan your preparation journey. So please do register yourself. It is completely free. It is completely free of cost, but it is going to be beneficial for all of you. And another announcement, there is a workshop going to happen taken by Dheeraj sir and Ashutosh sir on 4th of April in the evening at 7:30 p.m. for all those aspirants who are going to start their GATE 2024 preparation. They will guide you in detail how to plan your strategy, how to plan your preparation, so that it becomes most efficient. So before starting your preparation, you should understand these points, important do's and don'ts, so you can get the best possible rank in your GATE 2024 examination. All right, let us move to the next one. The question is from kinematics. The velocity components for a two-dimensional fluid flow, incompressible flow, are given by this. Velocity components are given by x component and y component of velocity. It can be concluded that the flow does not satisfy the continuity equation. What is the continuity equation for two-dimensional incompressible flow? You should remember the equation for continuity equation for two-dimensional incompressible flow. Because once the continuity equation is satisfied, then only the flow is possible. Without the continuity equation, flow cannot be possible. So the continuity equation says del u by del x plus del v by del y is equal to 0. So if you see the LHS, what is del u by del x? Del u by del x is equal to 1. What is del v by del y? That is minus 1 del v by del y. So it is 1 plus minus 1. That is equal to 0 RHS. It means it is satisfying the continuity equation. The flow is satisfying the continuity equation. The flow can be possible only when it satisfies the continuity equation. Otherwise, the flow cannot be possible. Whether the flow is rotational or irrotational. So we define the angular velocity omega about z axis is equal to half into del v by del x minus del u by del y. This is the expression for angular velocity. This is the expression for continuity equation. So what is del v by del x? Del v by del x minus 4. What is del u by del y? That is minus 4. Both are minus 4. So it is half of that is minus 4 minus minus 4. Are you getting it as 0? It means irrotational flow. If the angular velocity is 0, irrotational flow. The flow is irrotational. C is the answer. You should memorize these formula. The session is to brush up or revise your formula. Questions are not tough, but the formula revision is important before going to appear for your actual examination. The next one, question number 8 on your screen. The area of a 2-meter long tapered duct decreases. Area is decreasing. It is like a nozzle. And this is the change in area. This is how the area decreases, where x is the distance in meter. Inlet is having x is equal to 0. This is x is equal to L. The flow is in x direction. This is x. At a given instant, a discharge of 0.5 meter cube per second is flowing in the duct and is found to increase at the rate of this. What is this? dq by dt. Rate of change of discharge is 0.2 meter cube per second square. Rate of change of discharge is 0.2 meter cube per second square. The local acceleration at x is equal to 0 is. Can you solve it? Can you get me the answer for this? Now, at any section, can you let me know whether the flow is steady or unsteady? The flow is unsteady. Why the flow is unsteady? Because q is a function of time. So unsteady flow. And the flow is non-uniform also. The flow is non-uniform also. Why? Because velocity is a function of space also. So there is a local acceleration also. There is a convective acceleration also. The flow is unsteady and non-uniform. Convective acceleration will also be non-zero. Right? So at any section x, at any x, and at any instant, we can say q is equal to area into velocity, or we can say vx is equal to q by ax, isn't it? Vx is equal to q by ax. Now if we find out the local acceleration at this x, that is del vx by del t. And what is vx? Del by del t, q by ax. And area is independent of time, so that can be written as 1 upon ax into del q by del t. That is the expression for local acceleration. And put the value of a. And what is del q by del t? That is 0.2. So the local acceleration at any x is given by 1 upon 0.5 minus 0.2x into 0.2. That is the expression. Now if we want to find out the value at x is equal to 0, then the local acceleration will be, at x is equal to 0, the local acceleration 0.2 is divided by 0.5. That is 0.4 meter per second square. Isn't it? 0.4. 0.4 meter per second square. Can you find out the convective acceleration at the same location? Convective acceleration is given by Vx into del Vx by del x. Vx can be written as q by ax into del by del x. Vx can be written as q by ax. So q can be taken outside because q is not a function of x. So it will be q square by ax into del by del x 1 upon 0.5 minus 0.2x. Do the differentiation. So it is q square. Q is 0.5. So it will be 0.5 square upon ax into, it will be minus 1 into 0.5 minus 0.2x to the power minus 2 into minus 0.2, isn't it? And this is nothing but ax only. So 0.5 square into 0.2 upon 0.5 minus 0.2 x cube. This will be the expression for convective acceleration. This will be the expression. And at x is equal to 0. At x is equal to 0, then it will be 0.5 square into 0.2 upon 0.5 cube. What is the answer? This will get cancelled out. So again it will be 0.2 by 0.5. It will be 0.2 by 0.5, that is 0.4. So convective acceleration at x is equal to 0 is also 0.4. I hope this is clear. Local is also 0.4. A local at x is equal to 0, we are talking about. Local acceleration is 0.4. Convective acceleration is also 0.4. So the total acceleration is equal to local plus convective. That is 0.4 plus 0.4, that is 0.8 meter per second square. That is the total acceleration of the fluid. Second last question for the day. Again from the kinematics, the streamline equation passing through the point 2, 3 will be. Amit, you should continue your preparation. If your preparation is up to the mark or you need a slight push, then you should not leave your preparation in the middle. You should continue your preparation. You will get selected. Give it one more chance, and even if you are not able to make it, then you can take the admission in MTech. But because you are already in the preparation zone, preparation journey, you should not leave your preparation in the middle. The streamline equation passing through point 2, 3 will be. We will start with the differential equation of a streamline. What is differential equation of a streamline? dy by dx is equal to v by u, or we can say this is called a slope of a streamline. Slope of a streamline. You should give one more chance. Slope of a streamline. So what is the value of v? V is equal to a. U is also a. So we can say it is a by a1. So from here we can say dy is equal to dx. If we integrate, then y is equal to x plus c. To find out the value of c, we will put this point 2, 3. At 2, 3, it means y is equal to 3 is equal to x is equal to 2 plus c. C is equal to 1. So y is equal to x plus 1 is the equation of the streamline. Y is equal to x plus 1 will be the equation of the streamline. And the last question for today, the stream function in a 2D flow field is given by this expression. Then the magnitude of velocity at point 1, 1. We should know del psi by del y is equal to u and minus del psi by del x is equal to v. So del psi by del y, what is that? That is minus 2y. U is equal to minus 2y. And what is minus del psi by del x? That is also minus 2x. So v is equal to minus 2x. So at 1, 1, u is equal to minus 2 into 1, that is minus 2. V is equal to minus 2 into 1, that is minus 2. So u and v will be minus 2 each. And the magnitude of velocity is equal to under root of u square plus v square. Under root of minus 2 square plus minus 2 square. So that will give rise to 2 root 2. That will be 2 root 2 magnitude. B is the answer. Can you find out phi as a function of x and y for psi is equal to x square minus y square? For the given stream function, can you find out the corresponding velocity potential function? Can you find out the velocity potential function? So if we differentiate this, then we can say d phi. If you differentiate, then we can say d phi is equal to del phi by del x into dx plus del phi by del y into dy. So del phi by del x is equal to minus u into dx plus del phi by del y is equal to minus v into dy, isn't it? U is equal to minus del phi by del x, v is equal to minus del phi by del y. Put the value of u and v. Put the value of u and v. So d phi is equal to u is equal to minus 2y. So it is 2y dx plus v is equal to minus 2x. So it will be plus 2x dy. If we integrate this, then phi is equal to 2y into x plus 2x into y. That is 4xy. Phi will be given by 4xy. That is the corresponding velocity potential function for the given stream function. 4xy. Phi is equal to 4xy. Is this clear? So that is all from my side for this session. Tomorrow we will be having the numerical practice session for the fluid dynamics. I have covered fluid statics. Statics part I have covered in today's session. Tomorrow we will be having the numerical practice for formula revision for the fluid mechanics part 2, that is dynamics, ideal flow as well as real flow. That is all from my side, guys. Thank you for joining in. Please do not forget to like and share this session so that it reaches to all your friends and colleagues. So let me sign out now. Take care, stay safe, have a good day and a great future ahead. Thank you, guys. Thank you very much. Jai Hind.